that is the point where whole mass of the scale we can find out, right? Mean the maximum mass of the scale that will be here at the center, right? So that is the center of mass. But BSc examination, IGCSE examination, or any XYZ examination, they ask the question in a very different way. They never ask the question about the center of mass. They will give you a tricky situation. Now, what is the situation? The situation is that we are using this type of arrangement, right? You see, the same thing is there in the question paper, right? The same thing. We have a scale, means we have some 1 meter long wire or 1 meter long rod, right? Okay, but at one point it is fixed, right? The one point is fixed means this point, right?
Yeah.
The fixed point that is kept over a weighing machine, okay? One point is fixed. The other point which is at 90 centimeter from that fixed point, right? Other point which is at 90 centimeter from the fixed point, the fixed point that is the axis now. You understand my point? The fixed point is the axis, or that is a pivot. Okay? So 90 centimeter from the fixed point, we apply a force, right? And how much force is there? The force which is holding the scale. The force we can see here, right? This is around 20 gram now. Yeah, okay, you can see in the scale, right? That is a, this is 0, then 10, then 20, right? Okay, is it visible to you? Okay, let me change. Can you see it now?
Yeah.
What is the reading now you have?
Like
should be a bit pushed.
it's 5, sir. 5 grams.
Not, it's not 5 grams, it's 50. It's 0, 10, 20, 30, 40, 50. So how much is there? 50. Okay, and how much is here?
52.15.
So you see, when a force is there, upward force which is holding the scale, right? There is a downward force also. And what is the downward force? 52.17. You are understanding my point?
Yeah.
When I uplift something upside, right? Means when there is an upward force, definitely on the other side there is a downward force, because the Newton's laws says that forces all the time they exist in pairs, right? If there is an upward force in one side, definitely there must be a downward force on the other side. Understanding my point? So what is the upward force now here? 50.
And 40.
It's 40 or 50? 40, right? So upward force here is the 40, but here the downward force is
52.17.
okay.
18.
Understanding my point? So when there is an upward force in one side, there is a downward force on the other side. This is called moment. This is called moment or torque. So our question is where is the question? A hook is used to lift a metal plate, means a spring is used to uplift a scale or a metal plate. An upward force, in the question the upward force is 100, but our upward force is 40. Our upward force is, but in the exam the upward force is, Brian, in the
100.
exam upward force is 100, but our upward force is 40, right? Is needed to uplift the metal plate about the pivot, right? This is the pivot, this is the fixed point, right? As shown in the figure. So now we have to find out what is the weight, downward weight at the center. We know the weight, we know the force at the pivot, we know the force, upward force at the 90 centimeter from the pivot, but we are asked to find out the force, the downward force at the center. How we can find out that? You see, the BSc or IGCSE, they ask very typical type question. You are understanding my point? There is a upward force at 90 centimeter, which is 40 Newton, and there is a downward force at the pivot, which is 52.17 Newton. But you have to find out what is the downward force at the center, exactly at 50. How you will calculate? Or if they ask you, find the force at 40 centimeter, at 30 centimeter, or at 60 or 70, any random position, how you will find out, right? So question is clear. We have one upward force at 90 centimeter. We have the downward force at the pivot. Now we are asked to find out the force, the downward force at the 50 centimeter, right? So you see 50 centimeter from the pivot. 50 centimeter from the pivot. Find the value of W. Understanding the point?
Yeah.
Right? 50 centimeter from the pivot. Okay. So let me solve it for you. Okay. So go to the board. Right? When moment of force or torque. Right? So the formula which is used, the formula is torque is equal to force multiply distance between the between axis and force. Right? So what is the formula? Torque or moment of force, that is equal to force multiplied distance between axis and force. Right? So torque, that can be written like this. Torque is equal to force is F, and distance we can use multiply R. Right? So this is force is in Newton and this is in meter. Right? So let me make the diagram. So the diagram we have a road which is 1 meter long, means 100 centimeter. So this is a 100 centimeter long road. Okay, and this point is fixed, and this point is called the pivot, or you can call it axis. Right? So here this is pivot, or you can call it as axis. Right? Axis. And at a distance of this is center, this is called the center, so we can use this is 50 centimeter, and then at 40 centimeter this is 40 centimeter, right? So at 40 centimeter we have a spring, right? We have a spring, and the reading in this spring, this is means spring is applying a vertical force. F is equal to 100 Newton. Okay, the reading in the spring is, right? The reading in the spring is 100 Newton, right? Now we have to find out the value of W here. W, what is W? What is W? What is the value of W? Clear?
Yeah.
Now, when there is a upward force in this side, there is a downward force in this side. Right? Already I showed you in the weighing machine, because there is some weight here. Right? So when there are two forces, one is upward, other is downward, then it means there is a torque. Torque means rotational effect of force. Or moment is a rotational effect of a force. When force try to rotate something, then that is called a moment, right? Rotational effect of a force, that is called moment, or that is called torque. So when we have a torque, then how we can find out W? So by using the formula, torque is equal to force multiply the distance between the axis and the force. Now force is clear, 100 Newton, right? This is clear, this is 100, right? Now what is the distance between the force and the axis? 90 centimeter. But we have to change it into meter, because Newton is a SI unit, and we have to use the distance also in the SI unit. And when the sound question that was wrong because of the units. Okay? So keep in mind everything that should be in the same units. Right? So now we can use torque is equal to force is 100 Newton multiply distance is 90 centimeter, means 90 divided by 100. Now this is meter. Clear? This is in Newton and this is in meter. Now we can cancel 100 by 100. So torque is equal to 90 Newton meter. right? But we are not interested in torque. We want to find out this W. How to find out W? And W is a force. W is also a force. That is also a force, downward force, right? That is a downward force. So how to find out the W or downward force? Both are same thing, right? Again, I will use the same formula. Torque is equal to, now this is a downward force. Downward force, I can write it as FD, downward force, right? So FD multiply, again distance between the downward force and the axis. Now what is the distance between the downward force and the axis?
50 centimeters.
Yes, 50 centimeters. So now I can find out FD. So FD, that will be equal to torque divided by D. So what is torque? 90 Newton meter. And what is distance? 50 centimeters.
0.5.
And again we have to change it into meter, right? So 50 divided by 100. Okay, so that can be written as 90. This 100 will go up. This 100 will go up. Okay, and this will be 50. So 10 cancel. Now this is 180, right? So the downward force FD is equal to 180 Newton, right? So WD is equal to 180 Newton. When there is an upward force of 100 Newton at a distance of 90 centimeter, then in that situation there is a downward force. Weight is a force also, right? Then there is a downward force of 180 Newton, right? So now you see what is happening. What is happening? So if I reduce the distance, means from 90, if I move 40 centimeter back, so what happens? What happens? What happens? You see,
The force increases.
the force is increasing. The downward force is increasing.
Sir, what is that equal amount? Z equals to F times.
R. Oh, you can use the distance, right? You can use R. R distance. R. You can use D or you can use R. No problem. Okay, guys. So now you try this question. Mahadevi. Okay.